Okay, good morning. This is your introduction to algebra, and this is for Wednesday, the 22nd. Today we're going to do a little reviewing. I went over your tests. Some of you did fine, some of you struggled, some of you got a little confused on a couple of concepts. So I want to go over them and make sure everybody's on the same page. We're going to do a lot of this for the next couple of weeks because you have to be able to do this when you get into Miss Argueda's class, okay? So let's look at the first one. If 4x minus 9 is 47, what is the value of 11/4 x minus 12? Well, the first question is, which equation can I answer? I can answer the first question because it has a value assigned to it, okay? So we have 14x minus 9 equals 47. So what are we going to do? Our goal is to get x by itself. We have a coefficient with our x, and we have a constant. Let's get rid of the constant. It says to subtract 9, so we're actually going to add 9. I'm going to write it down so everybody sees it. These are going to cancel, giving us 14x equals, and we go over here, we have 47 plus 9 gives us 56. Now, what do we do now? We have to get rid of the 14. Do the opposite. It says to multiply, so we're going to divide. This gives us x. Now we say 14 goes into 56 4 times. So x is 4. Now, of course, that's not our answer. What do we do now? Take this value and put it into what is the value of this. It says 11/4x minus 12. What is that if x equals 4? So what are we going to do? Well, we're going to substitute that and say 11/4 times 4/1 minus 12. Well, this is going to cancel, giving us 11. 11 minus 12 is -1. So the value of 11/4 x minus 12 is -1. Now I'm going to erase that just to give us a little room on the board. And let's look at the next one. What if we have 3, write these down, do them with me, it'll help you. If you have 3/8 minus 36 equals a -12. What is the value of 3/4 x minus 5? Again, which equation can you solve? That's the first one. So we're going to say 3/8 x minus 36 equals a -12. So the first thing I'm going to do is what? Get the constants together. That means I need to get rid of this. I'm going to add 36 to each side. This is going to cancel, giving me 3/8 x. And when I go over here and I'm going to add this -12 and this positive 36, I'm going to get 24. Now what do? I need to get rid of the 3/8. So I'm going to put 8/3, and I'm going to multiply this 8/3. Okay, these are going to cancel, leaving me x. 3 goes into 24 8 times. This is 1, so x equals 64. Again, that's not our final answer. 64 is only the value of x. The question is, what is 3/4 x minus 5? Okay, we wrote our equation. Now substitute. 3/4 times 64/1 minus 5. This is going to cancel. 4 divided by 4 is 1. 64 divided by 4 is, we're going to take 4 into 6. That gives us 1. We have 24, and that's 6 times. Now we say 3 times 16. So we have 18, then we have 48 minus 5. Our answer is 43. Okay? If you have a question about an equation, and then it gives you an equation that says, now what's the value of this equation? Here's what you need to do. Work the equation with the equal mark. Come up with an answer for x equals what? It's going to be some kind of a constant. In other words, it's a number, okay? Then take that number, substitute it into your second equation and solve. That's the value that you're looking for. Now, let's look at this. 5c times 3m plus 2p plus c. Write that down on your paper. 5c times 3m plus 2p plus c. Now, when you are solving these problems, it's a multiplication problem, okay? You're going to multiply 5c times the first term, which is 3m, okay? We don't care about this. All we're looking at is this first term. A term is from the parentheses to the first process, the addition or subtraction sign, okay? So we have 5c times 3m. Well, let's start with the coefficients. What's 5 times 3? 15. So write your 15 down. Okay? With c, there are no other c's over here, so we're just going to write c. And there's no other m, so we're going to write an m. That's all there is to the first term. For the second term, that is the positive 2p. Okay, that's the second term. We've already used the first term. We don't care about it anymore. We're not to the third term, so we don't care about it yet. We're only looking at the second term. Now say 5c times 2p. 5c times a positive 2p. So 2 times 5 is 10, and it's positive because both numbers are positive. We have a c and we have a p, but neither one repeats, so all we have to do is write cp. Now, there's no coefficient, so that coefficient is really a 1. So we're saying 1 times 5 is 5. And c times c, or a letter times itself, it becomes the square because I can't solve it. So it becomes c squared. So my answer to 5c times 3m plus 2p plus c is 15cm plus tcp plus 5c squared. Okay, let's look at the next one. We're going to do the same thing. We're going to take this right here, our factor that's outside the parentheses. We're going to multiply this factor by the first term, then this factor by the second term, this factor by the third term, this factor by the fourth term. Okay, so let's do the first one. 7mp times m. There's no coefficient, so we say the coefficient is 1. So 1 times 7 is 7. M times m gives me m squared because I have 2 m's. Okay, so m squared. P, but there's no p in the first term, so we only write p. Plus, now we're going to take our 7mp times the p. Okay, so we have 7 times 1 is 7. M, there's nothing to multiply it by. P times p is p squared. Now, we have x. There is no x in this term. So we're simply going to multiply 7 times 1 is 7, m, a p, and an x. Because there's nothing to square because it's the only ones there. Look at the last one. We have 7mp times positive 2mp. Well, 7 times 2 is 14. M times m is m squared. And p times p is p squared. So our answer is 7m squared p plus 7mp squared plus 7mpx plus 14m squared p squared. All right? So now, I hope that makes more sense. What we just did was called the distributive property in algebra. We're distributing the multiplying by going to each term, okay? So when you see a multiplication problem like this, that's all you do. Take the first term, the one that's outside the parentheses, multiply it by the first term. Then go back and multiply the outside times the middle term. Then the outside times the last term. Now I want you to look next to it. I'm going to turn my camera a little bit. This is a little different. On these problems, I have m squared plus c cubed plus 3mm plus c squared c. There's no multiplication going on. What am I doing here? I'm adding. Now for some of you, adding these is very, very simple. Others of you are struggling knowing which ones to add together and which ones you can't add together. They need to be the same, remember? So we're gonna say this means mm plus c plus 3mm plus c. Now all I did was take the squares, and instead of writing c squared, I wrote 2 c's. Okay, so I had a c squared and a c. So there was 2 here and 1 there, so I wrote 3. That is only to help me know which terms are alike. I have 2 m's here, and I have 2 m's there. And 2 m's means what? It means m squared. I don't have a coefficient, so if I don't have a written coefficient, the coefficient is 1. So I have 1 plus 3 is 4. You're geniuses, okay? 4. But that's 4m squared. Why? Because mm means m squared. Now, I have 3 c's here and 3 c's there, and 3 c's means c cubed, right? And I have 1, I have 2, so I'm going to say plus 2c cubed. Okay? Pretty simple. So look at the next one. We're going to do the same thing. We're going to break them down. First, we have p squared, which means pp, plus 3am minus 2p, that's a p squared, p plus aam. Now, I did that so that it's easier to understand. I don't need that line if I understand my squares and my cubes already, okay? Can I add p squared to another p squared? There isn't one. So it's simply going to be p squared. Okay? I have 2. Remember, I'm not worried about the coefficients. I'm comparing only the value, the variables. 2 a's and an m. Oh, well, there's 2 a's and an m over here. There's 1 here and 3 here. So now I have 4a squared m. Here I have 3 p's, and it's the only place I have them, so I'm just going to write minus 2p cubed. Okay? Now, let's go back and look at this. We have, in your book, it asks you to write, look here, number 22. Number 22 on problem set 110, if you hadn't realized that yet, I'm sorry. Problem set 110, problem 22. It says to write this decimal as a decimal without a fraction. Without a fraction. All right, well, the first thing I have to ask myself then is, what does 1/4, what represents 1/4 as a decimal? Well, it's 0.25, right? So we're going to put 0.000, because there's 3 zeros here, 3 zeros here, 6. The 1/4 becomes 2/5. That's all it's asking you for. Change your fraction to a decimal. Well, a decimal would be 0.25, so we're just going to put it back out as 2.5. Okay, here we have 1 and 1/2%. If you look at your book, on number 23, it wants us to write this as a decimal. So the first thing I have to ask myself is, what is the decimal 1/2? It's 0.5. So write 0.4.5%. That is not the answer they're looking for. They asked you to make it into a decimal. But step 1, change the fraction to the decimal, which makes it the 0.5. Now, move your decimal point and drop your percent sign. Which way are you going to move it? Move it to the left. How many places? 2. Because percents mean 100. 1, 2. So this becomes 0.045. That's the decimal. How did I do that again? Let's look at this. We changed the 1/2 to 0.5 because that's what 1/2 equals. We learned that a long time ago. So I have 4.5%. Now to get rid of the percent sign, I'm going to drop the percent sign and move my decimal 2 places to the left. 1, oh, I don't have enough places, so I have to annex a 0. So it's here, and I went 1, 2. Now let's look at the last one. 6 and 3/8. So your first question, 3/8 is what decimal? Hopefully you remembered that it's 375. So this is 6.375%. Now let's move our decimal point. How many places? Move the decimal point 2 places and drop your percent sign. Ready? 1, 2. So I'm going to have to put 0.0635 and drop your percent sign. Okay, I hope this helped you today to get through some of the context issues. I know we have a couple more that we're going to do before I let you go. Okay?